Finding angles using sine, cosine, and tangent notes. First, let's review sine, cosine, and tangent. Remember our phrase, so-ka-toa, reminds us which sides of the triangle we are using. For sine, remember, it's opposite over hypotenuse. Opposite hypotenuse. For cosine, it's adjacent over hypotenuse. Adjacent hypotenuse. And for tangent, it's opposite over adjacent. Opposite over adjacent. To quickly review how we would apply this to a triangle, let's find the sine of angle A. Here is A. Sine is opposite over hypotenuse, so the opposite side from A is 3, the hypotenuse is 4. So the sine of A would equal 3/4. Find the cosine of angle B. Cosine is adjacent over hypotenuse, so the adjacent side to angle B is 3, and the hypotenuse is 4. So the cosine of B is 3/4. The tangent of angle A is opposite over adjacent. So from angle A, 3 is the opposite side, and 5 is the adjacent side. So tangent of A is 3/5. If you get stuck, just remember so-ka-toa. Now, to use this information to find an angle would be as follows. Find the measure of angle A. So I'm interested in this angle. I have to look at the information that is given to me in the triangle, and you'll notice that I am given 3, which is the opposite side, and 5, which is the hypotenuse. So I need to figure out which trig identity, sine, cosine, or tangent, uses opposite and hypotenuse. Well, sine uses opposite and hypotenuse. So to find angle A, I'm going to use the sine function. Now, sine of A should equal the opposite side over the hypotenuse, so 3/5. Now, turn this fraction into a decimal by taking 3 divided by 5. 3 divided by 5 is 0.6. Now, all trig identities come with a table. This is a table of sine. There's also a table for cosine and another table for tangent. You'll notice this table is set up where the first column is the angle measurement, and that's in degrees, and the second column is the sine, and those are decimals. And you can see it goes from every angle from 0 all the way down to 90 degrees. So all I have to do is find my sine in the sine column, and that will show me the angle. So since in our example the sine is equal to 0.6, I simply move down the chart until I find 0.6. Now you see this first column ends at 0.4, so I have to go to the second column. And I keep moving down until I find a number as close as I can to 0.6. You may not find it exactly, but just get extremely close. So this is close, 0.6018. So the angle would be 37 degrees. So over here, I would say A equals 37 degrees. Let's try another example. This says find the measure of angle B. So now I'm looking for angle B. Again, I survey the triangle and decide which two sides they have given me. Well, 3 is the adjacent side to angle B, and 5 is the hypotenuse. So I have adjacent and hypotenuse. Adjacent and hypotenuse suggests cosine. So I would write the cosine of angle B is equal to the adjacent side divided by the hypotenuse. Again, you always turn these into decimals, so take 3 divided by 5, and that's 0.6. Since I'm using cosine this time, I have to use the chart for cosine. You notice this chart is labeled cosine. And it's set up exactly the same way. Angle in the first column, cosine in the second. So I'm searching for a cosine of 0.6. You'll notice it's in the third column. Get as close as I can to 0.6, and that tells me the angle must be 53 degrees. So angle B equals 53 degrees. For our third example, I want to find the measure of angle A. Again, I survey the triangle and decide which two sides do I have. Well, I have the opposite and the adjacent sides. Notice I'm not given the hypotenuse. Opposite and adjacent suggests tangent. And tangent of A is opposite over adjacent. Divide the fraction. 3 divided by 4 is 0.75. Since I'm using tangent this time, I need the chart for tangent. And I'm looking for 0.75. Again, it's set up in the same way. Angles in the first column, tangent in the second. So I'm looking for 0.75. You'll notice in the second column, I can find a number very close to 0.75. So that means my angle is 37 degrees. So A would equal 37 degrees. For our third example, I want to find angle A and angle B. So for angle A, you'll notice I have opposite and hypotenuse, so that is sine. So sine of A would equal 20 over 40. Divide it on your calculator, you get 0.5. Since I'm using sine, I need to use the table for sine, and I need to find as close as I can to 0.5. You'll notice this time I found it exactly. So that means angle A was 30 degrees. For angle B, you'll notice that 20 is the adjacent side and 40 is the hypotenuse. Adjacent and hypotenuse is cosine. So the cosine of B must equal the adjacent divided by the hypotenuse. Again, divide those on my calculator, I get 0.5. So now I need the cosine table, and I'm looking for 0.5. Again, you'll notice I found this one exactly, which means my angle is 60 degrees. For my last example, I've given you the entire triangle, all three sides, and first I want you to find A using sine. Well, sine of A equals opposite over hypotenuse. So I divide 24 divided by 25, and I get 0.96. So I need to look that up on the sine table. I'm looking for a sine of 0.96. You'll notice that this will be in the third column. This is as close as I can get, 0.9613. So the angle would be 74 degrees. You can do the same things using cosine and tangent. And each time we should get 74 degrees. For cosine of A, I would use adjacent over hypotenuse, so 7/25, which is 0.28. Using the cosine table, I find 0.28, which is at the top of the third column. That's as close as I can come, 0.2756, and it says the angle would be 74 degrees. Same thing I found when I used sine. And for tangent of A, I would use opposite over adjacent. Again, divide 24 divided by 7. I get 3.43. And now I would use the tangent sheet and look for 3.43, or as close as I can get to it. 3.48 is as close as I can come, so again, it's 74 degrees. So I found A using sine, cosine, and tangent.